are you doing today? Well, my name is Jacob Bauldock, and I'm here to talk to you about the Kids for Chemistry program and my science fair project. So, we've been doing Kids for Chemistry for 2 years at ESCO, and it's been a great experience for the kids who've done it here. So I encourage anybody who has kids to let them participate in this program so that they can learn great chemistry. It starts in January and it's for 8 weeks, so just let them come in and try it. And also, Kids for Chemistry, if it wasn't for this program, I probably wouldn't have gotten second place at Coriel and second place at Delaware Valley. So this is a great program once again. So if you can just bring the kids in, then they may win some projects too. I mean, some science fairs too. And here's a video of me winning at the Delaware Valley Science Fair. So once again, Kids for Chemistry helped me win that award. So Kids for Chemistry also goes through all of these topics. The first 20 items of the periodic table, ions, acids and bases, oxidation and reduction, organic chemistry, and takes you all the way up to electrochemistry, which is actually what my project was based off of. So let's take a look at that. My project. Working on it. My project was the efficiency of a split cell reactor over a single cell reactor. Now you may be wondering, what's a single cell reactor? Well, that's it right there. It just has one cell, so you can just use like a cup, a regular cup like I did. And here's a single cell reactor, a split cell reactor. As you can see, it has 2 cells, and I'll explain why that may be more efficient. And here are my results, which I'll get back to. But you can see that those 2 lines that are high but don't last very long, that's the current of a single cell reactor. And the current that lasts long but doesn't go very high, that's the current of a split cell reactor. And I'll explain why one's higher and one lasts longer later. So now I'll explain the electrolysis of the sodium chloride solution. First, we have sodium chloride, which is just this atom molecule right here. And it consists of sodium, number 11 on the periodic table, and chlorine, number 17 on the periodic table. Now they came together because they had lonely electrons, so they decided to share one. So they came together to form sodium chloride. Now when you put this molecule in water, they split apart, and they have a tug of war for the electrons they were sharing. Chlorine wins because it has a stronger electronegativity. So when it pulls an electronegativity is the strength of an atom to pull an electron away from another atom. So it pulls apart and becomes a chloride ion. And an ion is anything that has a positive or negative charge. Since it has more electrons, which has a negative charge, than protons, which have a positive charge, it's a negative ion. And now sodium is a positive ion because it has more protons than electrons. And in the cell, there are two wires, the positive wire and the negative wire. And since opposite charges attract each other, they go to those wires. Now when chlorine goes to the wire, it loses its electron when it touches it because the wire has a strong electronegativity than the chloride. So the wire goes out the wire, through the battery, through the ammeter, and back down into the water where it meets the proton. Now before I explain this any further, I want to talk to you about water. People sure you love water, drinking it, you need it, but it behaves in a strange way. That proton right there, it jumps off of the water molecule. And it can just keep on jumping on and off and on and off and on and off if it wanted to, which it does. When it jumps off, it leaves behind the hydroxide ion, which is another negative ion. And then when the electron comes down and the proton jumped off, it jumps onto the proton. It didn't jump onto the sodium because, once again, the proton has a stronger electronegativity than sodium. So when it jumps on, it forms the hydrogen atom, which is the first atom on the periodic table. Now, two of these hydrogen atoms can come together and they form hydrogen gas and they bubble out. Chlorine can do the same thing. They come together from chlorine gas and they bubble out. While sodium and hydroxide ions stay in the water and they form sodium hydroxide, which is a basic solution. Now, here's the downside to the single cell reactor. So many sodiums start to collect up near negative water that this chloride is confused whether to go to all those positive sodiums or the positive wire. This is why I think that the split cell reactor is more efficient, because now it has two cells. So it has an agar salt bridge, which is a gel-like bridge that are made out of agar, water, and salt. And now the sodium will have to travel through or migrate into the cathode cell, which is the negative cell. So they start to collect up over here, and now the chloride just knows to go to the wire, and the same thing happens. The electron goes up the battery, through the wire, through the ammeter, gives the ammeter a reading, then back down to the water, where it's proton, and everything happens again. Except now it'll last longer because it's not going to get confused. Now once again, here's my results, or as I like to call it, my time study. These two currents up here, those current of split on the single cell reactor, like I said earlier. And the reason it's so high is because it's quicker than the split cell reactor. Because in the split cell reactor, the sodium had to migrate through, which took a longer time. But for the single cell reactor, all I had to do was just go right over. So that's why you have a high current right here. And it's longer for the split cell reactor because, well, it takes a longer time to, migrate over to the cathode cell. So it doesn't go very high though because it's not quick enough. But it lasts longer because it's longer. So in conclusion, if you want a high current, the single cell reactor is more efficient. But if you want a longer current, the split cell reactor is more efficient. And that's my project. Also, so if you can, let your kids participate in the physical chemistry program, and it'll be a big help for them when they get to high school.
Okay, think back. How many of you could have done that when you were going to 8th grade? I would have been running for the beach.